Try it again. Okay, thank you. Thank you for keeping track of it. Okay, so we now have 5y plus 5 equaling 10. And therefore, to solve this, I'm going to subtract 5 from both sides. This will give me 5y equals 5. When I divide by both sides by 5, I get y equals 1. So I got the answer for my second number is the number 1. The first number we get by doing x equal, now I can do this. X equals 4y plus 5. So it's 4 times 1 plus 5. And that gives me 4 times 1, which is 4 plus 5. So x turns out to be 9. So the first number turns out to be 9, and the second number turns out to be equal to 1. So that's how we solve a system of equations using setting a word problem, sometimes called a verbal problem, a real life situation problem, where we've changed from the English language into the algebraic language and used it to solve our equation. Okay, I want to show you another type of example that will show you how to use, again, a system of equations in a verbal problem. This type of question is quite frequently a quite frequent type of questions. Usually it's a question that involves a situation where something is being sold for a specific amount of money. Okay, Jesus, thank you for telling me. I'm going to mark you here. Okay, so listen to this question. Again, I'm going to put the pertinent facts on the board, and then we're going to switch from words to equations. Okay. Chad sold 30 decorated sweatshirts. He had 30, he went to a flea market or something, and he sold 30 sweatshirts. And he had 2 types. He had white sweatshirts that cost $10 each. And he had black sweatshirts whose price was $15 each. Okay, so here he sold these 30 sweatshirts, which are a combination of black and white shirts. He received a total of $390 for the sweatshirts. And we want to know how many black shirts he sold and how many white shirts did he sell. Okay, we know he says a total of 30, but it could be 10 of one and 20 of the other. It could be 29 of one and 1 of the other. It could be any combination. So we want to know how many of each kind of shirt was sold. Now, again, there are 2 types of things being sold here. We're trying to find the answer to 2 things: the price of the white shirts the price of the black shirts. So I'm sorry, no, we know the prices. We're not looking for the price. We're looking for how many white shirts were sold and how many black shirts were sold. Now, always picture in your mind or write down, what are you looking for? Specifically, we're looking for how many white shirts were sold. And that's number one, what we're looking for. And number two, we're looking for how many black shirts were sold. Now, if you write down what you're interested in finding, that'll right away tell you what you should use for your variables. The first thing we're looking for is how many white shirts. Let's call the number of white shirts, or how many white shirts, let's call that X. Now remember, there's two things that can be involved with the white shirts. It could be the price of the white shirt, or it can be how many he sold. Let's keep in mind that we're not looking for the prices. We already know the prices. What we're looking for is how many white shirts. Let's be very specific when we write our legend. And let's call how many black shirts that were sold, let's call that Y. Okay, now we're ready to write our system of equations. We have two variables, we need two equations. So let's go back to the very first fact that we were given. We were told that a total of 30 sweatshirts were sold. What equation will give me that fact? 30 sweatshirts were sold in all. Anybody have any idea what we should write as an equation?
X plus Y equals 30.
Perfect, perfect. X plus Y equals 30. Remember, X is how many white shirts were sold, Y is how many black were sold. Altogether, 30 were sold. So our first equation, the result of the fact that 30 sweatshirts were sold, is the equation X plus Y equals 30. If you notice, we didn't make use of any of the fact that the white shirts cost $10 and the black shirts cost $15, because when we were told how many shirts were sold in total, it had nothing to do with the price of those shirts. But we now need to write another equation. And in that equation, we have to take into consideration the price of each shirt and the total amount of money that was made. So how do we do that? Well, if each white shirt costs $10, then the amount of money that we make from selling white shirts is 10x. X is how many, let's say you sold 10 white shirts, 10 times 10, you'd get $100 for that. So you have to take the number of white shirts and multiply it by the price of the white shirt to get how much money you're making out of the white shirts. Now, this $390 includes the white shirts and the black shirts. So we have to add 15Y, because 15Y is the amount of money he's making from selling black shirts. Each black shirt is $15. He sold Y of them. So my second equation, 10x plus 15y equals 390, is the equation that takes into consideration not only how many were sold, but what the price is. So notice, when we were just talking about how many there were, we just used plain X and Y. But when we're talking about how much money we make, not only must we take the X's and Y into consideration, but in each case, the price of each item. Now, we now are set up for our system of equations. Let's see how we would solve this system of equations. So I'm going to just let's say I decide I want to get rid of the x's, which means that on the top equation, I'm going to multiply it by 10. The bottom equation, I'm going to multiply by 1. And since both of these are positive, I need to multiply one of them by a negative. It could be the top equation or the bottom, but I don't use a negative on both of them. I only use it on one because I want one to come out positive and one to come out negative. So if I do that, my top equation becomes negative 10x minus 10y equals negative. So negative 10 times 30 is negative 300. That's multiplying this equation by negative 10. The bottom equation we're multiplying by 1, so it stays 10x plus 15y equals 390. And when we add these two equations, again, I use the elimination method because they were set up as x, y equal number. So here we have negative 10x plus 10x, which cancels out. Negative 10y plus 15y, which is 5y. And negative 300 plus 390, which gives me positive 90. And when I divide both sides by 5, and you can take out your calculator and do this, 90 divided by 5 is 18. It turns out that y equals 18. In other words, he sold 18 black shirts, so sweatshirts. How many white sweatshirts did he sell? Well, let's go back to our original equation, x plus y equals 30. That's pretty easy to do. So what we're getting is x plus 18, is my y, equals 30. And when I bring the 18 to the other side, I get x equals 12. And now I know he sold a total of 12 white sweatshirts and 18 black sweatshirts. Okay, I'm going to give you another one to try, similar to this. This is not going to, this is a similar situation, but instead of selling shirts, here we're selling tickets. And that's a very common situation. There's a bunch of somebody selling tickets to a movie or a theater or to a concert, and they're different types of tickets. Some are adults, some are children, and they have different prices. Let's see if we can solve an equation, a system of equation, a word problem that we can set up a system of equations for that situation. So here's what we're going to do. And I'm going to give you a few minutes to try this out on your own. Okay. So we have tickets to a local movie were sold at $10 for general admission. So this general admission is $10, and $6 was the cost of each senior ticket. So we have these two types of tickets. The regular price, which is $10 a ticket, and $6 if somebody's a senior. Now here's the information that we have. 190 tickets were sold. And the total amount of money that they got for those tickets was $1,300. This is the total number of tickets, not including their price, just knowing that how many tickets there was 190 tickets. But the amount of money they collected was $1,300, And we want to know how many general admission tickets were sold.
My boyfriend on a date today. I took my boyfriend on a date today.
I'm sorry, is somebody trying to say something to me?
I took my boy. I took.
I'm muting everybody again. You want to say something, either send me a chat or unmute yourself. Okay, I'm giving you a few minutes to try this question. Kim, what kind, there are two types of tickets that were sold, so you have to indicate which of each type were sold. Well, I want to know, you were saying 40 general admission tickets were sold. Okay, great. We'll see if that's the correct answer. Okay, I think that we are ready to, a couple of people have answered the question, so let's see if we can do this together. Again, it's a similar situation that we had before. We had two types of things that are being sold, and they have different prices, and we want to know how many of each type are sold. So again, we have to assign a variable. So I'm going to assign, let's call X, how many general admission tickets were sold. Again, that's what I was asked to find. How many general admission tickets were sold? So that gives me my first variable. My second variable is the other type of tickets. So let's see how many senior tickets were sold. Let's call that Y. And now we have our scenario. We know that the $10 were the cost of the general admissions and $6 was the cost of the seniors. And a total of 190 tickets were sold. Now notice the 190 tickets has nothing to do with the price of the tickets, just how many that were sold. So when we write our equation, we write X plus Y equals 190. We don't use the $10, we don't use the $6. It has nothing to do with the fact that the 190 tickets were sold. It's just the total of how many tickets we had. So that's our first equation. Our second equation has to take into consideration the price of the tickets, because we're told that a total of $1,300 was made for selling these tickets. So not only does it involve how many tickets were sold, but also the price of the tickets. So now I include my general admissions, the number is 10, is X. I'm going to multiply that by 10. So I will get 10X for the amount of money he's getting for the general admission tickets, plus 6Y is the amount of money that we're getting for the senior tickets. That total is the $1,300. And again, we now have our system of equations. And again, we have to solve this system of equations. And since we were specifically asked how many general admission tickets were sold, we're looking for X. Usually we're asked for both and it doesn't matter, but in this case, since we were told specifically, we want to know how many general admission tickets were sold, we want to figure out what the X is, which means that when we're solving this, we want to eliminate the Y. Again, we're using the elimination method because these are both in standard position. And since it's a Y that I want to eliminate, I'm going to multiply my top equation by 6. My bottom equation by 1, and since they're both positive, I need to use a negative with one of them. I generally go with a negative going on the first equation, but it could be the first or the second. So let's see what we get when we multiply the top equation by -6. We're going to get -6x minus 6y, because I'm multiplying the y by -6. Okay, now this I don't know in my head, so I'm going to use my calculator. I'm going to multiply -6 times 190, which gives me -1140. The bottom equation, I'm multiplying everything by 1, so it stays the same. 10x plus 6y equals 1300. And when I add the negative 6x and the positive 10x, I get 4x. Here I get negative 6y and positive 6y, it gets eliminated. That's what we're trying to do. And negative 1140 plus 1300, again, I'm using my calculator for that, gives me a total of 160. And when I divide both sides by 4, I get x, I don't want to go too low here, I get x equals 40. 160 divided by 4 is 40. And that was the correct answer for the people. A lot of people did give me that answer. 40 general admission tickets were sold. That obviously means that 150 senior tickets were sold, but we were not asked for that. Be very careful when you're doing these problems that you answer the question that's being asked. Not only do you have to write the right equations, but sometimes people they might say 150, but which would be correct for senior, but that's not what the question was asking. Okay, so this was a similar situation. Does anybody have any questions about these? Some reason. Is anybody else having problems with the Zoom? I'm having a little bit of a problem. Hello? Do you hear me?
I can hear you.
Oh, okay.
But
Yeah,
some
I can
people are
hear-
saying they
I can
can't
hear
hear you.
you.
Oh, wait.
Okay. And you can see the board.
Yeah, I can
Yes.
see it.
Okay, great. Okay. All right, so that basically takes care of our chapter on systems of equations. That was chapter 3. I'm going to be going on now to chapter 4. As I said, chapter 4 is a chapter on polynomials. We're going to do a review of working with polynomials, which means we're going to learn how to remind ourselves how we add and subtract and multiply. Dividing multiple polynomials, we're going to leave for another chapter. We are actually going to do that topic, but that's going to be in this chapter. We're doing addition, subtraction, and multiplication, and most importantly, factoring. Knowing how to factor polynomials is a very important step in dealing with algebra. So that's what we're going to be talking about in this chapter. Okay, so let's first remind ourselves what we mean by when we have a polynomial. So I could give you something that looks like this. 3x to the third minus 8x squared plus 4x minus 15. If we look at this algebraic expression, we'll see that we have a total of 1, 2, 3, 4 terms. A term is something that everything is connected with the operation of multiplication. For example, my first term is 3 x to the third, which merely means that you're taking 3, you're multiplying it by x, and x. Remember, exponents is just a quick way of writing a multiplication. This first term is 3x cubed. The second term in this expression is minus 8x squared. Again, everything here is connected by multiplication. Then we have plus 4x, and then we have negative 15 or minus 15. None of these are what we call like terms. In order for terms to be what we call like terms, we need the letter part, the variable part, to be identical. Each letter in the term has to be the same, and each exponent on that letter has to be the same. In this case, sometimes we have more than one variable in the same expression. Here we only have one variable, it's an x. This is an x to the third. This is an x squared. They are not like terms because even though they both have x's in them, one has an exponent of 3, one has an exponent of 2. So that's, this expression cannot be simplified any further. Nothing can be combined. We can only combine things that are called like terms. The only thing, and when we have like terms, the coefficients, the numbers in front can be different, but the letter parts have to be identical. So let's say I gave you an expression that looks like this. Negative 4x to the third minus 6x squared minus 2x plus 10 plus 5x to the third. I'm going to go down here. Minus 5x squared plus 6x minus. And I'm told to perform the indicated operation. Obviously, the operation between these two expressions is the operation of addition. Now, I'm going to show you how I always approach these. You could just line them up one under the other, but I'm going to do what I've always done. Where I see parentheses, I'm going to remove the parentheses. And in order to remove the parentheses, I have to consider as if there's a 1 in front of each of those parentheses. So multiplying everything in the first parentheses by 1 will just give me negative 4x cubed minus 6x squared minus 2x plus 10. Multiplying by a positive 1 doesn't change anything. The second parenthesis is also has a plus 1 in front of it. So that becomes plus 5x cubed minus 5x squared plus 6x minus 10. So I get rid of my parentheses. Being careful, if there is a number there, a coefficient, I multiply, use the distributive property. Okay, now that I have everything lined up in one line, I'm going to look for like terms. So I have a negative 4x to the cubed. The only one that looks like it is the 5x cubed. They both have x to the third. So I combine the negative 4 and the positive 5, which gives me positive 1. So that gives me 1x cubed, or just plain x cubed. Then I go to the next term. This is a negative 6x squared. Is there any other x squared term? And yes, there's an x squared term and a negative 6x squared and a negative 5x squared. Again, I combine, when I'm combining like terms, I just work with the coefficients. Negative 6 and negative 5 is negative 11. So that becomes negative 11x squared. Then I go to the next term that I see, just check this off now. The next term I see is a negative 2x and a positive 6x. Those are like terms because they're just x's. Again, I combine the negative 2 and the positive 6, which gives me positive 4x. So now I've taken care of the x's. And finally, have positive 10 and negative 10. When I combine them, it just gives me 0. So my final answer to this example is x to the third minus 11x squared plus 4x. Notice this happened to have had 4 terms. This polynomial, when we combine them, we only ended up with 3 terms. By the way, if something has 3 terms, it's called a trinomial. If something has just 2 terms, it's called a binomial. And if something is just a single term, it's called a monomial. Anything more than 3 terms, we just give it the generic name of polynomial. But our answer in this case turned out to be a trinomial. Okay, let's try one more. Let's try one that involves subtraction. Suppose I gave you this example. Negative 4x to the third minus 6x squared minus 2x plus 10 minus 5x to the third minus 5x squared plus 6x minus 7. Okay. What I'm going to do in that case is exactly what I did before. I'm going to remove the parentheses. But remembering that since there's no numbers in front of these parentheses, it's going to be understood that it's going to be a negative 1. A 1 in front of this one, and this is going to be a negative 1. So I'd like you to try that and see if you could come out with the right answer for that question. Okay, I think we can start working on this. This, when I multiply 1, just stays what it was, negative 4x to the third minus 6x squared minus 2x plus 10. The second parentheses, we're multiplying everything by -1, which essentially changes every sign. So it becomes negative 5x to the third plus 5x squared minus 6x plus 7. So anything that was positive became negative, anything that was negative became positive. And again, I do what I did before, and I combine the like terms. So here I have the negative 4x to the third and the negative 5x to the third, which is giving me negative 9x to the third, because negative 4 and negative 9 and 5 together give me negative 9. Then we have negative 6x squared and positive 5x squared. So negative 6 and 5 is negative 1. So I'm just going to write that as negative x squared. Then I have a negative 2x and a negative 6x, which is giving me a negative 8x. And finally, I have a positive 10 and a positive 7, which gives me positive 17. And again, there's nothing more to combine. These are not like terms. So this is my final answer.
Would the answer be wrong if you put a 1 in front of the negative x squared?
Absolutely not wrong. The only thing is that if you're doing an open-ended test where you're just supposed to give an answer, that would be completely correct. If you're doing a multiple choice test, it's unlikely that they will put the 1 there, and you have to recognize that if that really means this is negative x squared is the same as negative 1x squared. Okay?
Okay, thank you.
Okay, so now let's go on to multiplication of, because that was addition and subtraction. I think most people are quite familiar with that. Let's talk a little bit about multiplying of polynomials, and then that'll leave us with going on Tuesday to start the concept of factoring. But today we're just going to end up with multiplying of polynomials. So I'm first going to just talk about what is the idea when we are multiplying monomials, just one term times one term. Suppose I have something like 6x cubed y to the fourth, and I want to multiply it by negative 2x squared y 7. This is a single term because everything is connected by multiplication. This is a single term. We want to multiply these two monomials together. Now, unlike adding and subtraction, you do not need like terms. You can multiply any two monomials or polynomials together. How do we do that? Let's start with the monomials. We start by multiplying first the coefficients, the numbers. The 6 times the negative 2 is negative 12. And then we multiply the letters together. We multiply the letters by adding the exponents. So if we have an x to the third times an x squared, we add the 3 and the 2, and that gives us x to the fifth. And then we multiply the y's together. Y fourth and y seventh, 4 and 7 is 11. So my final answer becomes negative 12 x fifth y 11. There could be more letters involved as well, but basically we multiply by adding the exponents. Now, what happens if I have a situation like this, where I have let's first talk about a monomial times a polynomial. Let's say I have 2x to the fifth multiplied by 4x squared minus 10x plus 16. This happens to be a monomial, 2x to the fifth, times a trinomial. There are three terms here. And I think everybody's going to remember that what you do is you just use the distributive property. You're going to take each term in your trinomial and multiply by this 2x to the fifth on the outside. So multiplying the first term is 2 times 4 is 8. Again, when we're multiplying the letters, we add their exponents, so that'll give me x to the 7th. Then I have 2x to the fifth minus 10x, which will give me negative 20x. And here we have to be careful. I don't see any exponent on the x, but we know if there's no exponent written, it means the exponent is 1. So this is a 5 plus a 1, that gives me x to the 6th. And finally, I have 2x to the fifth times 16. So the 2 times the 16 is 32. And I just bring the x to the fifth over. And that would be my answer for multiplying this monomial times the polynomial. You just use the distributive property. I'm going through this pretty quickly because I think that most of you know this from previous examples. So let's just talk about what happens when we have a binomial multiplied by a binomial. Suppose I have 5x minus 2 times 3x plus 7. Suppose I want to multiply this binomial by this binomial. I'm first going to give you the general rule, and then I'm going to talk about something that's called FOIL. What we're going to do is basically use the distributive property twice. We're first going to take the 5x and multiply everything in the second parentheses by 5x. And then we're going to go on and multiply everything by the negative 2. So we're going to get 5x times 3x, which will give me 15x squared, because x times x is 1 and 1 is 2. Now we're going to take the 5x and multiply by the 7. So that's going to give me 35x. I've now multiplied everything in the second parentheses by 5x. I now have to go on and multiply everything by the second term, which is negative 2. So I'm going to take the negative 2 and multiply it by the 3x, which will give me negative 6x. And then we'll do negative 2 times 7, which is negative 14. If you notice, we got 4 terms because we multiplied 2 in the front times 2 in the second equation. But if I look very carefully, I see that I have like terms. These middle terms, the 35x and the negative 6x are like terms and they can be combined. So I get 15x squared. The 35 minus 6 is 29, so that becomes plus 29x and minus 14. And my answer by multiplying the two binomials turns out in most cases to be a trinomial. Notice this is also sometimes called FOIL for first, outer, inner, last. It's just a reminder of that we have to make sure to multiply all four things together. First is the 5x times the 3x. Those are the two first terms. That gave us the 15x squared. Outer are the terms that are furthest apart, which is the 5x and the 7. That's what we did now. After this, we took the 5x and multiplied it by the 7, and that gave me the 35x. Inner are the two closest. Yes?
I'm sorry, I had a question, but continue explaining and I'll ask you.
Okay. The inner ones are the negative 2 and the positive 3x, so that gives us the negative 6x. That's our inner. And last are the two last terms in each parentheses, the negative 2 and the negative 14, and the negative and the positive 7, which gave us the negative 14. So again, this is just telling us the four multiplications we're going to get. And again, I'd say in 90% of the time, the inner and the outer, the first, are going to be like terms, and they're going to be able to be combined so that you end up with just 3 terms in your final answer, not 4. Occasionally you do it. Yes.
Okay, I couldn't figure out at first how you got the 2 over the square over the 15x, but I figured that out. So
Okay.
what would you, so if it was a 5x square and a 3x square, you would multiply the 5 by the 3 and then add the exponents, correct?
Absolutely.
Okay.
Exactly it. So when you're multiplying terms together, the numbers on the outside, which are called the coefficients, are multiplied. The exponents are added. Again, remembering if there is no exponent indicated, it means that exponent is 1. If there's a letter and it has no exponent, it means the exponent is 1. Okay, I think we're going to stop right here. I'm going to give you some homework on Delta Math. No, I don't think I'm going to give you any homework on Delta Math. I just want you to, anybody who has not taken the test yet, make sure to do it by Tuesday. So we're going, by Tuesday, everybody should have taken the test. If anybody took the test and was not happy with their mark and would like to have a second chance at doing it, just email me and I will reset your test so that you can start from scratch. If anybody's entitled to extra time, then please let me know. I haven't gotten any information from any of the departments, but if you know that you're entitled to extra time, please let me know so I can adjust your test for extra time. Okay, everybody, you should have a nice weekend, and what we're going to be continuing from is this study of polynomials. That's what we're going to be next time.
Thank you again, Professor. So the time will still be 45 minutes, correct?
Yes. Again,
Okay.
if you feel you need more time, then just let me know and I'll give you some more time. This is everybody, anybody. Okay, have a nice weekend, everybody.
You too.
You
Bye-bye.
too. Thank
Bye.
you. Bye-bye.
Bye. I'm closing the,
Did you take attendance, Professor?
yes, I did. Who is this that's asking me?
Ismail.
I saw that I saw that you would come in afterwards, so I changed it. I originally marked you absent, but I marked you here.
Okay, thank you.
Okay,
Have a good day.
you too.